Maximize cloud efficiency with Do It, the trusted partner in multi cloud management for thousands of companies worldwide. Visit doit.com. That's DOIT.com. Do It, your cloud simplified. Welcome to Day 2 Cloud, you awesome human being. Today we're talking about chaos. Well, I mean, chaos engineering with Matt Schillerstrom from harness.io. He's going to educate us a little bit about what chaos engineering actually is and why you might want to implement it in your organization. What stood out to you there, Ethan?
That chaos engineering is very focused on the engineering part of it. That is, there is a method to how you do chaos engineering. It is very structured. There is an expectation of what might happen, and there's a whole process built around it. So, though it sounds chaotic, it in fact is not, Ned.
Ooh, is that irony? I'm not sure. You have to check it out and judge for yourself. Enjoy this episode with Matt Schillerstrom. Matt, welcome to Day 2 Cloud. We're excited to have you here. I understand that you are a senior product marketing manager over at Harness. What does that entail and what does Harness do?
I've been a product marketing manager now for a year and a half. And what that means is, I'm helping our customers and prospects and whatnot just try to like understand the product and technology, but also like understanding their emotional pain points with using it.
Hmm.
So, besides writing blogs and doing webinars, I'm meeting with people and learning their pain points and just helping them navigate the software delivery lifecycle of what Harness does, which is CI/CD, so continuous integration, continuous delivery, as well as feature flags and chaos engineering and SLO management and Gen AI stuff too. So all the above.
Oh, okay. So it's a broad category of different things that you're covering there. Now, before you went to go work at Harness, my understanding is that in your previous roles, you were an early adherent to the idea of chaos engineering, which is something that Harness is also focused on. So, how did that early rollout of chaos engineering start? And what the heck is chaos engineering for those unfamiliar with it?
I got started with chaos engineering in my career in 2016, shortly after like Kubernetes came out. Specifically, I was like an IT disaster recovery planner at Target,
Okay.
like an architect developer role. And I was working with some of our teams and updating their DR plans and working on the next test. And my friend was like, "Hey, I'm on Kubernetes now. I don't need to do any DR testing. Kubernetes is self healing." So I was like, "Wait, what do you mean? Like Kubernetes can fail, right?" And they're like, as I'm Googling Kubernetes because I hadn't even heard of it myself. And he's like, "No, it's self healing. Everything just works." I'm like, "Okay, I don't know if that's true or not." So I was like quiet back then. And I just said, "Okay, I believe you. I'm going to go work with somebody else to see what we need to do." And I started Googling things and like chaos engineering popped up then. And like that's kind of like how I first heard of it was from Google and everything out there. And like somebody telling me that Kubernetes fixes everything. But as you know, like it doesn't.
No. All systems can fail, right?
Yeah. So where that began, right? My friend at the time, right, was like, "Hey, I'm on Kubernetes. The system is resilient. It just fixes itself, restarts pods automatically. Your app is good to go." But then I started like researching Kubernetes and like, okay, there's resource exhaustion issues. There's other constraint parameters in Kubernetes that happens. Like, how do I test this, right? And I've always been of the philosophy like you need to understand like how something is working, when it's working, when it breaks, like how are you going to fix it, right?
Mhm.
So what I ended up doing was just finding out some failure modes within Kubernetes on their documentation, understanding like what frameworks could you use to test it. And that's where like chaos engineering popped up from Netflix. So like starting back with like the Chaos Monkey tool, if you've heard of that, Netflix adopted that as they're transitioning from their on-prem data centers to AWS, and they're killing EC2 hosts randomly throughout the business hours, 8 to 5 while their engineers were on there because they didn't want to like kill a random server at 2 o'clock in the morning and make their engineers wake up. So we actually started doing that at Target where I worked. So started to like work with engineers, randomly killing their servers just to see like the behaviors, to see if they could see it in the dashboards or monitoring tools, make sure that they weren't susceptible to like single node failures of their application. Also just like again testing like the human processes behind that as far as like, hey, if something happens, can I see it? Can I respond? Do I know how to work through it.
So how would you say chaos engineering fits into the larger availability and reliability landscape? Is it a replacement? Is it an augmentation of, say, a backup and disaster recovery?
Specifically, like at Target, what we were doing, so we had an IT disaster recovery program that was kind of like your old school once a year snapshot of reliability. But
Hmm.
back in 2016, we started changing it and shifting it over to that continuous resilience, continuous reliability, because as we had went from monolithic to microservices, we were going from, monthly changes of our product to like multiple times a day. And as all
Right.
those things kept changing, like the DR test that you just got done doing is now out of date. 10, 15 years ago, maybe your DR test, once a year was okay, maybe twice a year. But now it's like everything changing so fast, like it's like out of date almost immediately, right? So where that came into play at Target was just kind of validating that not only are we going to have like the least amount of downtime as possible, but the highest availability at the right cost, because we didn't want to just like over provision and have like really expensive servers and stuff, but just actually like testing it for that availability that it would actually respond to our customer. So
As someone who also did a lot of disaster recovery work as part of my consulting job, I always would tell folks that I was consulting with, you need to test your DR plan more than once a year because your infrastructure
Yeah.
changes more than once a year. And back then, that was true, but not nearly as true as it is now. So I totally get
Hmm.
yeah, as soon as you're done writing that DR plan, it's probably already out of date. However, looking at chaos engineering, I would say like breaking things on purpose seems like the antithesis of what SRE and ops is all about. We're trying to keep stuff up and running. So the people on the ops and the SRE teams are probably going to object to the idea of you just wandering in and virtually unplugging servers. How do you overcome those objections? Like, what benefit are those teams going to see?
yeah, I had this conversation at Target all the time because people just didn't get what chaos engineering was. And maybe it just had a bad name at the time, right? Because they would often say, I already have enough chaos in production. Why would I want
Right.
more? Right. And breaking things on purpose sounds fun to some people, but most people, especially around production environments, they don't want to. So the conversation that I would have with all these people was first, let's look at your prior incidents that you've had within the past week or past month. And I would talk through how you could leverage proactively like chaos engineering to test that, right? To either like figure out if you're susceptible to that risk or if you can mitigate it or lower the impact. So one of those things back in the day, like we were implementing resilience mechanisms in our code. So like timeouts, retry logics, circuit breakers, using like tools that Netflix created, like Hystrix for circuit breakers. This was back in like 2016, 2017. So teams would implement those, but they wouldn't really test or validate it. They would run it, right? And it would work, but really they didn't understand like the tipping points of failure, right? They would wait till like an incident in the future unveiled that it didn't work. We would find these incidents and be like, hey, you can proactively use chaos engineering to inject like network disruptions in between your API endpoints or between your cache and your database to actually like trigger those resilience mechanisms to make sure that they did function. And then you can actually just like be confident that they're going to work, right? Or you'd at least understand when it wouldn't work. So like if you did get a phone call or a page, you at least know like what was probably breaking, right? So that's kind of like how you navigate those conversations. And it hopefully it makes sense. People listening, oh yeah, that makes sense. Why wouldn't you test, right? But like in reality, like how many things do you implement and just assume it works? And then all of a sudden, like later on, you roll the dice. Maybe an incident happens, maybe it doesn't. I don't know, right? Or maybe you're on your next job and you don't know all these failures because, they don't happen all the time, anyways.
Matt, I think part of it is just the change that we've seen in how we do computing over the last, say, 20 years. It used to be we relied so heavily on a single server, and that server, that one box had all this redundancy built in. We had multiple
Mhm.
power supplies, and we had a RAID array and multiple NIC connections, perhaps, and so on. And if we wanted to go bigger, we'd scale that box up. Okay, we got to move to a bigger box. We're maxing this one out. Well, now everything's distributed, it's all scale out. And so chaos engineering steps in. It's like, let's make sure this application is actually correctly going to run in a distributed computing environment. Let's mess with this thing and make sure it does what it's supposed to do. we didn't used to test that way. That wasn't the way it was done back in the day. So I think there's still maybe some old thinking that's still current thinking for some folks, depending on just where they're at with their applications.
Yeah, no, I couldn't agree more with that too. I mean, back at Target, we had transitioned from this monolithic Target.com to, microservices based architecture with, services that were decoupled, right? That they don't necessarily need to like rely on other systems like tightly coupled, right? Loosely coupled. But yeah, we had to definitely change the mindset, right? Like that growth mindset of like thinking different. What I would say to that, like for folks out there that are thinking about chaos engineering too, right? Like if you already do performance testing, load testing, which I don't think anybody like questions these days, like you can pair up chaos engineering with those easily because you can say like, hey, well, I'm doing load testing. So, for example, like at Target, like I'm simulating like hundreds of thousands of orders per hour for, a few hours just to make sure that my architecture is stable to that. Let's introduce some network failures, right? Like what happens when, latency between these endpoints increases by 2000 milliseconds, right? Like how does my system handle that? Because that will happen eventually, right? Or if I have auto scaling procedures like implemented, like let's force that during like performance and load testing to see what actually happens, right? Those are all practices that we put in place at Target because we didn't want to add like another thing to the engineer to do, right? Like another new thing, right? Like they're so bombarded with everything. So it's like, well, what can we stack on top of? Like if you've read some of the habit books out there, habit stacking is the best. So like if you like stack the habit of chaos testing with performance testing or load testing, it works really well.
Now, you said something about testing the network before. And as the resident network guy in Data Cloud, I don't know why you'd bother because networks never fail, obviously. So why would you even test for that? I mean, come on. Come on,
I know.
man.
I know you always get blamed.
We do, that is for sure.
It's always the network, right?
In the world of DevOps maturity, not everyone's in the same place as they're implementing DevOps as their shop. And there's a maturity model there that we can reference. When do I introduce chaos engineering into my DevOps world? What am I ready for that?
I'm a fan of implementing it right away. But
Okay.
what I would say is, if you are adopting microservices, if you're on Kubernetes, if you're doing this whole cloud native thing, right? Like those are definitely like keywords that should spark interest to doing proactive chaos testing. If you have DevOps in your title or SRE, like you should be doing chaos engineering too. So those are some simple things, right? Like what sparked it in my past career was being woken up too many times, right? Like incidents after incidents, and I was looking for something new and different, right? Or a new way to do disaster recovery testing. So that's kind of what prompted me. But if you're a manager out there and you want to get your team to like have that growth mindset and think differently and build for resilience, like you should look at chaos engineering and doing that proactive testing.
You mentioned a few keywords in there, like DevOps, SRE. Like if you're hearing those terms or you're part of that team, then chaos engineering should probably be on your mind. Does that mean that those are the teams that are responsible for setting up, managing, and maintaining the chaos engineering effort and like the tooling behind it?
Yeah, so I've seen so many different team structures around the org chart. After Target, I worked at Gremlin as a product manager for 2.5 years. So I worked with a lot of different customers on how they set it up. The best practices that I've seen, so I'll run through that. So, like site reliability engineers, I always say they're protectors of production. So I've seen SRE teams own chaos engineering, where they're taking like that production incident that happened, figuring out like what to fix, then they fix it with their development team, and then they use chaos engineering to like recreate that incident and then make sure that what was fixed was actually working, right? And they maybe even blow up the incident a little bit proactively just to see like how big of a repair job they needed, right? So I've seen that work really well with SREs. I've also seen platform engineering teams own it. So they provide chaos like as a service. So the platform teams basically provide the application teams like, hey, my system is going to be resilient to, 5,000 milliseconds of latency or resource exhaustion that consumes 80% of your pod. Then the app teams that just understand like, hey, here are the failure modes that I'm protected against and that are tested. So that's another best practice. And then like the third structure I've seen is, which is kind of rare, but developers, themselves, like doing some chaos engineering testing locally on their laptop, and then kind of like advocating to their infrastructure teams that they want to test this. Where it's hard, the chaos products out there, you really need your like infrastructure platform teams to test with you, especially like as you're installing agents or delegates or infrastructure. So it has to be that collaborative effort. But those are like the three. So like SREs, platform teams, and developers. And I'm definitely seeing the shift towards developers more these days.
Maximize cloud efficiency with Doit, the trusted partner in multi cloud management for thousands of companies worldwide. Doit's innovative tools, expert insights, and smart technology make optimization simple. Elevate your cloud strategy and simplify your cloud spend. Visit doit.com. That's DOIT.com. Do it. Your cloud simplified.
Who's the consumer of the chaos engineering then? If you got those three groups that are the ones that are implementing it, who are the ones that are the kind of the recipients of the results, or the ones that got to pick up the pieces if things go badly? One of the companies I worked at, we didn't do chaos engineering, but like the security team would do surprise stuff. And it could be like, surprise, we did a desk audit. You had a network diagram out on your desk and now you're in trouble. It could be a surprise like that. But other things they would coordinate with us on and say, yeah, we've hired this third party. They're going to be scanning the external network. Their source IPs are going to be this. So when you see that stuff come through, that's a known entity and it's okay. Don't freak out. In the case of chaos engineering, do you want people to be able to prep for it, or do you want to surprise them?
I think you can do both. Like, you don't want to be a jerk, right? I've seen from my experience, right? Like, I don't know if you've heard of the term game day or fire drill or like a business continuity exercise, right? But you can do these once a month pizza parties where you get together with a team and proactively test, right? And run different experiments. You can surprise them if you want, if you're testing like the human behind it, like how are they going to handle this pressure and response, right? And like one fun story with that too, in my previous life, like we had a tabletop exercise just like that. We were running chaos experiments on infrastructure, but we took a break and ran one on a person. And again, we weren't trying to be jerks, but we basically caused this failure. And we just were seeing like how long would it take the engineer to respond, right? Like from the page or the dashboard notification. And then what would they do about it, right? So the cliff notes here is that engineer, all they needed to do was like file a ticket to have Google go investigate and fix something because it wasn't within that engineer's control. Like he could not fix this, right? But that individual spent about 45 minutes, looking at dashboards, looking at notes, trying to figure out if he could fix this, didn't ask for help, right? And then ended up not submitting the ticket till later. And in reality, there was no like pass or fail with this test. It was like, hey, buddy, you're not on an island. You can ask for help. Like if it's 2 o'clock in the morning and you got paged, don't feel like you need to be up for 45 minutes trying to solve this on your own. Like call us, ask for help, like submit that ticket. Don't be concerned, right? And like those are just some small behavioral things that you can test like with that chaos engineering mindset, right? So besides like, infrastructure, auto scaling, like does your engineer know that they can ask for help, right? They don't have to like solve it on their own. So like that's one example of like not being a jerk. You're trying to make the human better.
The log shows that Bobby just signed out of the building and we got an email saying he resigned. That didn't go well at all.
Come back, Bobby. It's okay.
Yeah.
It was just a test, Bobby. Just a test.
I like that you brought in the human element that's involved in chaos engineering, because we typically get wrapped up in all the cool tools and technology and settings that you can tweak. But yeah, at the end of the day, someone is probably going to get a page or, an alert on the monitoring dashboard, and they're going to have to know what to do as a human being to help resolve this issue. And testing that ahead of time, being prepared, having gone through the training and the actual exercises means that when it does happen at 2 a.m., he's not going to spend an hour up trying to figure this out on his own.
Yep, exactly. One other question like that you'd asked too, just to go in a little bit more details, like, yeah, if you run a chaos test and the results show that something bad happened or will happen, like what do you do with it? And in my experience, a lot of times it just sits on that Jira backlog forever. right? Which it's good for the engineering team to know that that problem exists, so at least they can be prepared for it. But as a former product manager too, right? Like I need to manage that backlog and tech debt, and I need to enable my engineering team to like fix things. So I think if you are going to practice chaos engineering, like you need to have that good processes in place to like clean up that tech type issue. That's one way. But I've heard people say too, like they aren't implementing chaos engineering because they don't have time to fix anything.
So we don't want to know. I worked at a shop. We did disaster recovery testing quarterly, and we did it on the production environment. Do you typically do chaos engineering on the production environment?
Personally, I do. I don't see people starting there for sure. So most people start, in that dive environment or QA environment, like that lower environment, just so they don't run into unknowns, right? Like some people start in production, and I would say that you can, especially if you have the right tools in place. Like where I work at Harness with our chaos engineering product, we have a capability called Chaos Guard, where you can basically set up like a firewall to protect and minimize the blast radius, right, of your impact. So the tooling today is getting much better. But in general, you should start in lower environments. And then when you test and validate those like use cases and they're proven, and in essence, you've stopped learning, then you can like graduate to production, if that makes sense. So an example of that, right? Like if you have some auto scaling procedures that you've implemented, right? You can proactively run chaos tests to trigger those, right? And just make sure they work. And those are tests that you should do in production, right? Like that's a resilience mechanism that you expect to work during an incident, or before an incident. So you need to test that proactively.
Then one more question about this regarding what I'm testing. Am I just breaking infrastructure or am I attacking applications as well?
Yeah.
Not attacking, maybe like trying to find max load or, overload a system with too many requests, that kind of thing.
Yeah, it's a little bit of both. In principle, most of the experiments are infrastructure based, increasing CPU, from 10% to 100% to see how your application behaves, right? Or increasing memory, right? So these are all like infrastructure related experiments or, impacts, but ultimately, like it's how does your application handle an environment where there's like 80% memory and CPU consumption? Or if you could actually run chaos experiments on, your disk, like I'm going to fill up a disk, right? What happens when my disk is full? Like,
I can't write log entries anymore. I can't do any of the things you can't do with a full disk. Okay, what does the app do? Yeah.
those problems should be solved. We've all been through those pain points where all of a sudden it's like, wow, I haven't been writing logs for a week.
Yeah.
But still today, like in 2023, you see that like teams will run these experiments for failure modes and they see like, yep, this isn't working. Shoot, let me go fix it. Right. And at least they find out now instead of later when they actually need that. Right. And on the flip side, you can do specific application testing too. More of the products these days out there that you can either consume with open source or commercial can do some application fault injection as well. Just whether that's, like injecting different, like HTTP codes to see like how my system responds to that, right? Or just like kind of changing some header information and seeing how your application like behaves with that too. But mostly today it's like infrastructure. People are starting with that testing. But I imagine here in the coming future, application fault injection will be more prominent.
Right. One of the things that occurs to me when you're talking through all these different chaos tests and scenarios is I need to have like monitoring in place to actually find out these things are happening and how the system reacted to it. So I need like monitoring and logs already in place. If I don't have that, then injecting chaos engineering is just going to break stuff and I don't know. If I'm going to get started with chaos engineering, what other things, prerequisites, or skills should I have in place before I try to roll out a chaos engineering experiment?
Chaos engineering is very scientific method based, right? You're always trying to think about like what's going to happen when a system fails. So like besides any technology, like your team should have this mindset of just like thinking through like a hypothesis of what your system's going to do and then like understand like what might happen, even if they're wrong, right? So if your team can't think through that, then maybe you're blindly running some chaos tests out there, right? But hopefully, right, like that monitoring in place. I would say most teams do have some sort of monitoring in place already, which is good enough. If you have monitoring that says like, am I up or down? Like that's good. I mean, don't use your customer to tell you you're like up or down, right? But
Right.
I mean, some of the experiments I ran back in the day at Target like revealed that we didn't have the proper monitoring in place, right? So
Hmm.
like had we waited until we had thought we had perfection, like we would have never gotten there because we just didn't know, right? So as like a former like architect developer, like anytime I was like implementing something, I always wanted to understand more metrics than just like up or down, right? So like I leverage like service level objectives, from the Google SRE book or whatnot. But even then, I think a team, if they have a pager in place, you're ready for chaos engineering just so you can like cause some impact and validate things and see that failure. And if you can't see it, like if it was a surprise, then that's a good indication of something you need to go fix.
Right. That's a really good point. That part of the chaos engineering experiments is going to reveal some blind spots that you have in your monitoring solution. So there's a feedback loop there of improving what metrics you're tracking or what you're monitoring.
Exactly.
More than just simple up and down. Is it responding or not? It's like, okay, but we need to set a threshold for how quickly it will respond, perhaps. Some of this seems to involve a fair amount of planning ahead of time, probably meeting with some different teams, talking out what you want to test. In your experience, are there a few recommended, like, quick wins or things to look out for when you're in the initial stages of planning your chaos engineering experience?
Yeah, you can get really hung up on like just not starting is like where it just takes forever. I mean, what I've been saying, today, maybe I'm making it sound easy. Like it was a journey. Like my experience at Target was 4 years, 2016 to 2020 while I was there. And we did a lot, right? But it took a while to get started, right? And navigate the conversations and work with security and everything. But like again, I think the quickest win is basically working with the team, talking to them about their pain points with software delivery or being on call, like not even maybe even mentioning chaos engineering, and then just teaching and educating them like how chaos engineering can help with that initially, right? So a lot of times developers just get used to being on call or get used to like restarting something, right? Or following this process because it's tried and true and you just get complacent and it's like that's just what I always do. So you have to kind of like put yourself in their shoes, as they say, understand their processes, show them like a new way of doing things. And like that is often the win. Like the aha moment that I usually get from people is drawing out an architecture diagram, unless they have one already. But even if you're taking a whiteboard, right, and drawing it out with a marker, like, and talking through like how the system works, like at the transaction, like how does this work? At Target, like we are always selling bananas. So I use that as an example all the time. Like I'm buying a banana. Like, how does this go through target.com and checkout and all that? And let's talk about like what's going to stop me from buying bananas or what's not. And usually like those wins, like as people just start slowing down and thinking about how the system works, that's kind of like their aha moment. Then they're like, I want to do this testing. And then they're like, but when do I do it? Then we were like, well, we'll have to budget that into your sprint or like help you do some automation. But usually that was like the quickest win is just like having them slow down, teach them a few failure modes that they maybe, weren't aware of. And then like having their team kind of just be like, okay, we can work through this and fix it. Like engineers like to fix things.
Matt, nothing can stop me from buying bananas.
Yeah, exactly.
Listeners, you can't see, but I'm literally wearing a shirt that has bananas on it
Oh,
right
yeah.
now.
That's awesome. Yeah.
Now, Matt, I know you work for a company these days that does in part chaos engineering, but if I'm looking for an open source solution to get started with, and I'm looking at the CNCF landscape page, which is, as we know, a huge disaster. It's hard to keep up with the craziness of that page. Can you recommend maybe some standout tools I could focus on?
Yeah. So there's two tools on the landscape today. So one is Chaos Mesh, and the other one is Litmus Chaos. Litmus Chaos, Chaos Native slash Harness actually donated that project to the CNCF a few years ago. Harness acquired Chaos Native in 2022. Uma Makara is head of chaos engineering, and he donated Litmus Chaos with his team to the CNCF. So We are contributors, maintainers of that project. We represented that project at KubeCon in Chicago. I was at that booth talking to a lot of great people. So those are two projects. Like I prefer Lipness Chaos, but I'm also a fan of Chaos Mesh because we're trying to build the community, right, of chaos engineering within the CNCF and the Linux Foundation, right? And both of those are very cloud native focused. If you're running Kubernetes, you can use those straight out of the box. I always like to say, if you're familiar with deploying an application to Kubernetes, you can use Litmus Chaos or Chaos Mesh just like that. Because at the end of the day, it's a custom resource definition that you're deploying, and then that's causing like the impact to your system. So it's very simple. You can get started today. Both those tools have kind of like a shopping cart experience. If you go to litmuschaos.io, they have this great chaos hub of resources, and you can kind of click through, like I was saying before, like a shopping cart, right? And kind of just say like, I want a network experiment, or I want something that's going to impact my CPU, right? Or my disk, that kind of thing. So
When I'm installing these tools, is it putting some kind of an agent on remote nodes that I wish to perform chaos experiments on?
if you like the term agent, then yes.
No, I hate the term agent, but
I know some people are always like, ooh, an agent. And then security is always like, an agent. But I'm like, it's software, it's binaries that do stuff, right? So yeah, with Libnis Chaos, right? You're installing like that chaos infrastructure, and then that deploys the impact. And with Libnis Chaos too, like you get a whole control plane and UI and all that kind of stuff. So you're not doing like command line, interface. You can, but there's a great UI UX experience with these tools today. So like one of the people that went up to my booth at KubeCon with Libnis Chaos, they're like, this is a commercial product though, right? And I'm like, no, this is the CNCF open source project Litmus Chaos. It's that good.
Matt, part of my background is in security. And when I think about security testing, we would hire pen testers, we would hire vulnerability scanners and do vulnerability assessments, these kind of things. Does that sort of work and maybe some other security work factor into chaos engineering, or is chaos engineering and that kind of security testing, are those really separate disciplines?
I like to say there's definitely some synergies between the two. My prior role, we were building our own security platforms at Target, and the security engineers were leveraging chaos engineering to make their security systems more reliable, which is interesting, right? The discipline of chaos engineering, with just like the scientific method of forming a hypothesis, testing it, and having it very controlled. Like you'll see some other products in the industry that have taken that approach. There's a company called Mitikit with my friend Kennedy. So he's created some like security chaos engineering practices where you're actually like purposely like testing things or patterns in security that you expect, right? But I think that again, like a lot of it's just that mindset of like, what are my failure modes? How am I going to test and validate it? And then I can just understand. And I think that DevSecOps approach, which, is very mature, I think, in these days with lots of tooling, like that's where like chaos engineering will be. Like, right, it'll be just as popular as like DevSecOps, right? So you can see like even with some of the open source tools, you can see some security based tests where it might be around changing like some headers in your HTTP just to kind of see how your system responds to that, right? And that could be a means of like validating like security is in place.
Awesome. So, Matt, if someone's thinking about starting down the path of chaos engineering, what are some key takeaways or tips that you have for them?
Like the number one thing again is to kind of have that open mindset of why am I doing this? Like what's the value out of this, right? And the business value, right, as a developer is like I'm protecting my customer experience, right? And then also just like if you're a platform team, my customer is like the application developer. So again, the value there is that I'm helping my developer write their applications in a resilient manner. So like the business value there is that developer experience is going to be top of mind. After that, right, like just making sure you're having an open conversation with like your infrastructure team to let them know like the testing that's happening just so they can understand, the expected or unexpected. And I would just say, honestly, like whatever ticketing system you use, write a ticket about it because that's a really clean way to document what you're doing. And then you can share those results to other team members as well, right? Because you don't have to do this like in a silo. You can share your learnings And I think that's the biggest takeaway, like at Target, that we experienced is we started with one team. We had awesome documentation, even though I hate documentation. But we were able to share that story, right? So rather than just like a boring like log kind of a thing, we actually kind of wrote like a story. We told the story of how we, leverage chaos engineering to proactively test resilience mechanisms. And then other teams read that. And then rather than like actually running chaos tests at first, they actually implemented best practices with a lot of those circuit breaker frameworks. And then they ran tests after that to validate that it worked,
Hmm.
which it did. So in essence, like they didn't have to run chaos tests, right? Because they learned from somebody else, right? So
Gotcha. Learn from others' mistakes. Wouldn't that be a nice concept? I never do it, but I'm sure other people have. Cool. Matt, are you a social person? Is there somewhere people can follow you or some you'd like to direct them to learn more about chaos engineering?
yeah, so I'm on Twitter. My handle is Shilly Vanilli. Don't ask, don't ask.
Fantastic.
um, I'm also on LinkedIn. Profile's my name. But otherwise, like harness.io, we have a chaos engineering page. We write blogs and tutorials, and we have video content on that as well. So those are the main places to look for me.
Awesome. Well, Matt Schillerstrom, thank you so much for being a guest today on Day 2 Cloud.
Yeah, thanks so much, guys. Had a lot of fun today. Appreciate it.
Absolutely. And hey, awesome listener, virtual high fives to you for tuning in and joining us on this episode of Day 2 Cloud. If you want to know more about chaos engineering, you might want to check out our Kubernetes Unpacked podcast on the Packet Pushers family of podcasts. Episode 35 is all about chaos engineering in Kubernetes and the Litmus Project. How about that? If you've got feedback on this episode or ideas for a future show, you can send us a message. Go to packetpushers.net/FU. That's for follow up. Or you can reach out to Ethan or I on LinkedIn. We'd love to continue the conversation with you. Also at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros, including the aforementioned Kubernetes Unpacked about the realities of working with the Kubernetes ecosystem. It has some great crossover topics, just like this chaos engineering episode. So definitely have a listen to that. Until next time, just remember, cloud is what happens while IT is making other plans.